Good morning, friends. I am Dr. Atul, principal on B.Ed College. And now, today, we are going to learn about finding difference between pre-test and post-test. So, friends, whenever a researcher completed his or her research on MEd, MPhil, PhD level, then he or she should find difference between pre-test and post-test. If the researcher use experimental method in his research and obviously use single group design as a researcher design, then at the end of the research, he should analyze his data. For analysis, there are statistical tools like parametric and non-parametric tools. But in this video, we are going to discuss about parametric tool, that is t-test. Friends, if a researcher want to find difference between pre-test and post-test in single group design or post-test of control group and post-test of experimental group in equivalent group design, then he should know these things which is shown in the table: mean of pre-test and post-test, standard deviation of pre-test and post-test, and coefficient of correlation of pre-test and post-test. I repeat again: mean of pre-test and post-test, standard deviation of pre-test and post-test, and coefficient of correlation belongs to pre-test and post-test. So friends, let us discuss first how to find it, this mean, standard deviation, and coefficient of correlation with the help of Microsoft Excel. Let us discuss first how to find pre-test and post-test with the help of Microsoft Excel. First, right click, then new, then second last option, that is Microsoft Excel. You may provide here a name like pre-test and post-test. Whatever name, you should provide it for Microsoft Excel folder. Let's open it. Now, here are so many rows. In first row, A row, I will put it mark as example. Example. We will put marks in A row belongs to pre-test and B row belongs to post-test. But now we are going to put it, we are going to insert here marks belongs to pre-test. If our exam is related to 50 marks, then such marks like in pre-test, I will take only 10 students. For example, if here your data is related to 100 student or 200, whatever, you have to select as like 25 marks for first student, then 26, 27, 24, 28, 29, 23, 27, 28, last one, 29. Now I will insert the marks related to post test in column B. 34, 36, 38, 39, 37, 38, 39. These marks I am inserting as example. You have to put it your research marks. So here, my 10 student data are insert here. In A column, there are pre-test marks, and in B column, there are post-test marks. Now, I would like to go here in formula, then in F, first column, then selecting here average, third one column, that is average. Average means mean. Okay. Now, I would like to clear it and insert it A1 to A10. And now I am getting here a mean regarding to pre-test, that is 26.6. This is the mean. This is the mean, 26.6. This mean, this answer is here also in this column. Now let's take mean of post test. B1, 2, B10. Now here the mean of post test is 37.6. See here and here also. Okay, so this is the mean. Simple. Now let's find out standard deviation. Again, I would like to go here and now here select STDVA, third one. This is for standard deviation. Okay, again go here, everyone. A1, 2, A10. See here, 2.065 means 2.07 is the standard deviation belongs to our pretest. The answer is here as well as here. Okay, now standard deviation of post test. B1, 2, B10. See here, standard deviation is 1.57. Standard deviation is 1.67. Here, standard deviation decreases post test from pre-test. Okay, whatever, no problem. So this is the process to find out mean and standard deviation. Now, coefficient of correlation. See here, 1, 2, 3, third column, coral. Then okay. Here we have to insert here both column. A1, 2, A10. Then here selecting B1, 2, B10. See here, finding correlation or coefficient of correlation 0.08. 0.08 is the coefficient of correlation. So friends, using P data, we have to find these raw things. First, mean of pre-test, then mean of post-test, then standard deviation of pre-test, then standard deviation of post-test, and then coefficient of correlation between pre-test and post-test. How to find it, these things, I'm explaining here. Hope so all of you are definitely getting it. Now, let us discuss about an example which is related to pre-test and post-test. Let us discuss one example. One example is here. Mean of pre-test is 70, mean of post-test is 82. Standard deviation of pre-test 4, standard deviation of post-test, actually it is 6 here. Wait a minute. Standard deviation of post-test is 6. Here just wrongly mistake writing here 4. But standard deviation of post-test is 6. Then coefficient of correlation they given us 0.68 and number of students are 70. Step first, find standard error of mean. This is the formula regarding to standard error of mean. This formula regarding to standard error of mean. Standard deviation first divided by root n. And here we know standard deviation as per previous slide. I will show you. Standard deviation of pre-test here 4 and number of, see here, standard deviation of pre-test 4 and number of student 40. Hence, put it here in the formula. Standard deviation of pre-test sigma 1, that is 4, and root n 40. Root 40 is 6.32. 4 divided by 6.32, that is 0.63. 0.63, that is standard error of mean regarding pre-test. Now, as we have to find out standard error of mean regarding to post-test. Standard deviation of post-test is 6. Number of student 40. Root of 40, 6.32. 6 divided by 6.32, that is 0.95. So this is the standard error of mean regarding to pre-test, and this is standard error of mean regarding to post-test. Okay. Now we have to find out in step second, difference between standard error of mean. Difference between standard error of mean. So this is the formula. Standard error mean first square plus standard error mean second square minus 2 R. R means coefficient of correlation into standard error of mean first and standard error of mean second. We have to plot such values and finding here. Wait a minute, I would like to show previous slide. We have to plot values and finding here difference between standard error of mean. This is 0.49 and root of 0.49, that is 0.7. Next, finding t value. Post-test mean minus pre-test mean. Post-test mean minus pre-test mean divided by difference between standard error of mean. And our t value is 17.14. Now, finding table t value. For the table t value, we have to find out degree freedom, df. Formula of degree freedom, that is n minus 1. We know number of student is 40, hence our degree of freedom 39. So we have to find out both level in table t value, that is 0.05 level and 0.01 level. This is standard level. How to find out these values, I would like to show in this table. So use this table. This table must given in your exam. This is degree of freedom. See, this is degree of freedom. We have to find out 39 number. If 39 number is absent, then we have to take 40. It is closer to 39. We have to take 40 and 40 here and 0.01 and 0.05. These two values are most important. These two values are most important. Okay. Why 40? Because 39 is absent. Why 39? Because 39 is our degree of freedom, like in here. So on 0.05 level, the value, table value is 2.02. On 0.01 level, table value is 2.71. Now, interpretation. Research t value means 17.14 is greater than table t value. Remember this thing. If research t value is greater than table t value, then and then your difference between pre-test and post-test is significant. See, our research t value, this is our research t value, 17.14. This is our table t value, both table t value. So our table t value is smaller and research t value is greater. If research t value is greater than table t value, then difference between pre-test and post-test must be significant. That means your experiment must be successful. Okay, and if vice versa position, our table t value is greater than research t value, then difference between pre-test and post-test is not significant, and your experiment is not successful. So this is the process regarding to finding difference between pre-test and post-test and interpretation. Thank you.